Hello everyone, my name is Janderson. I am a PhD student of the University of Pernambuco from Brazil, and today I'm going to present an analysis of machine learning approaches for social robotic navigation. First, we have studied the current limitations of machine learning to solve social navigation tasks, and we have listed some of the most important challenges. They are high data dimensionality, high computational costs, difficulty in social situations, and variety in social norms. For example, the norms that work in a shop center may not work in a sidewalk. And this figure shows common situations of social norms applications. So, reviewing the literature on social navigation tasks, we found relevant works. The first, the social wire motion collision avoidance with deep reinforcement learning. It is a DRL model that aims to avoid collisions and adapt to social situations. And this model was tested in a pedestrian-rich environment with a fully autonomous robot. The second, deep motion, learning to navigate like humans. The model tries to learn using the paths used by humans, and it has a Gaussian distribution loss function to better generalize the model for acceptable paths variations that aren't displayed on the dataset. The CNN encoder is a deep encoder able to eliminate the useless paths using the shortest path. It was evaluated with fixed and dynamic obstacles. The Rainbow is a model able to play Atari games better than humans. And all these models are really good in the environment. But we made some tests and analysis, and we got that the first model has a bias for social norms that complicates generalization. As we can see in this figure, that Sen encoding really eliminates the useless paths in the train scenario, but on the other hand, it has serious problems with doing the same task in an unknown environment. So we found a behavior similar to the DRL and the other mentioned works. They only work well in known environments, and we can see in this table that the model trained on environment A didn't get a good win rate on the environment B. So, with all that was demonstrated in this discussion, the next step of this research will be based on solving the limitations using incremental learning. So we presume the models should adapt themselves to the new situations. For the changes, they need adaptations. And the main point is new situations will always come up in social robotic navigations. So we think a good way to solve this is to create models that can keep learning. So that's it, and thank you for your time.